Students, this is lesson U1A01. In this lesson, I will go over exercise U1A01b, which is solving a system of three linear equations. So let's take a look. You actually have everything in you to solve this, even though this problem here looks impossible, looks very, very scary. You are going to approach this in a very systematic and methodical manner, okay? And the way in which we're going to do this, we're going to eliminate one variable at a time. And the way in which you eliminate one variable at a time is you can only at most work with two equations at any given moment. Okay, so if you look at this, okay, just by inspection here, again, the rule of thumb, number one, is you can only work with two equations at any given moment in time. So which two equations should you work with? And between those two equations, which variable would be the most convenient for you to eliminate right now based on this setup? Again, pause the video to see if you can answer that question. So hopefully you guys looked at this, okay, and thought, well, it looks like equation 2 and equation 3 is set up really, really well for us to eliminate y's, okay? The x's and the z's don't really quite look that nice to eliminate, okay? You can most certainly eliminate the x's first, okay? But it'll require just a little more work. Why do that, right? So for this problem, I'm going to eliminate y. So how am I going to do that? I'm going to take the second equation, which is negative 3x minus 3y plus 4z is equal to 15. And I want to take the bottom equation, which is 2x plus 3y minus 5z. Notice how I'm rewriting the equation, and you should too. This is a good standard of practice. And what you want to do is we're going to add the top equation by the bottom equation. And if we do that, we'll end up with negative x. The y's will eliminate, and then I'll have minus z is equal to 15 plus negative 17, that's negative 2. So that's taking the second and third equation. What I'm going to do now is I'm going to take the first and second equation, and I'm going to do the same thing, and I'm going to try to eliminate y. I'm not going to try to eliminate anything else because the point is I need to get rid of all the y's from all three equations. So how am I going to do that? I'm going to take the first equation and the second equation, and again I'm going to write it out. So I have negative x minus 3y minus 6z. Again, the key here is calm and methodical. And then negative 3x minus 3y plus 4z is equal to 15. And what I'm going to do here is I am going to multiply the bottom equation here by negative and then add, okay? Or you can think of it as just subtracting the top equation by the bottom equation. Either case is the same thing. So negative x minus negative 3x, or negative x plus negative times negative 3x, whichever way you want to think about it. Either case, I will end up with 2x. The middle term disappears because negative 3y plus 3y becomes 0. The last term, I have negative 6z plus negative 4z, so that's minus 2z, is equal to, I'm sorry, not minus 2z, just made a big error there. So that's minus 10z, right? Because negative 6z plus negative 4z is negative 10z, is equal to negative 32. All right, so now I have these two equations. And what I want to do with this is, notice right now I have two equations and two unknowns. This is now super familiar territory. So I'm going to rearrange this as negative x minus z is equal to negative 2. And then I have 2x minus 10z is equal to negative 32. What I want to do with this is I want to rearrange this. I want to eliminate one of the variables. I want to make a decision here, and I've decided that I want to eliminate x's. So I want to multiply the top equation by 2. So I end up with negative 2x minus 2z is equal to negative 4. The bottom equation doesn't change, so it's just, again, stays the same. It's 2x minus 10z is equal to negative 32. I want to add the top equation by the bottom equation. If I do that, I'll end up with 0 and then plus negative 12z is equal to negative 36. Last, I'm going to divide both sides by by negative 12. I'll end up with z is equal to positive 3. And now that I have z is equal to positive 3, I can then figure out what x is. And it really doesn't matter where you place x, okay? The goal is I need to place it somewhere. And you can solve for z by placing it into some equation somewhere, okay? You can place it actually into any of these, okay? In any of those places, as long as you know what you've done after the manipulation is correct, that is, okay? So I'm going to take z is equal to 3, and I'm going to pop it into this guy right here, okay? So I have negative x minus 3 is equal to negative 2. I want to add 3 to both sides. I end up with negative x is equal to 1, or I end up with x is equal to negative 1. Now that I've solved for x and z, now I need to go and figure out what y is, and there is really no particular place that we can, can put x and z in to solve for y that will make anything any simpler. I'm going to place it into equation number 3. So I have 2x plus 3, I'm sorry, not 2x, because I already know what x is. X is negative 1, plus 3y minus 5z, so it's minus 5 times 3 is equal to negative 17. So I end up with 3y minus 17 is equal to negative 17. I'm going to add both sides by 17. I'll end up with 3y is equal to 0, or simply y is equal to 0. So I have all three unknowns figured out.